Hello everyone, this is Srihari, and today we are going to learn what is prime factorization. So the concept of prime factorization is learned when we are studying whole numbers, natural numbers, when we are learning about the factors of a whole number, when we are learning about multiples of a whole number, when we are learning how to find the common factors, common multiples of any given whole number. So, to understand what is prime factorization, first we need to learn about factors. So, suppose we are conducting a division operation between two numbers 10 divided by 2. So, 10 is called the dividend of that division operation, 2 is called the divisor of that division operation, 5 is called the quotient of the operation, and 0 is called the remainder of the operation. So, factors are basically all numbers, all divisors of 10 with which we get a remainder of 0. So 2 is basically one of the factors of 10 because when we divide 10 by 2, we get a remainder of 0 and a quotient of 5. So when we are getting a remainder of 0, then 2 is a factor of 10. So can you give some more examples? Yes, I can give some more example. For example, if we divide 10 by 5, so 10 divided by 5. So 10 is the dividend, 5 is the divisor, 2 is the quotient, and 0 is the remainder. So we are getting a remainder 0 with a divisor of 5. So 5 is also a factor of 10. So what are the other factors of 10? So I have listed all the factors of 10 in the screen here. So we have four factors 1, 2, 5, and 10. So when we divide 10 by 1, we get a quotient of 10 and we get a remainder of 0. Right? When we divide 10 by 2, we already know that we get a quotient of 5 and we get a remainder of 0. When we divide 10 by 5, we get a quotient of 2 and we get a remainder of 0. When we divide 10 by 10, we get a quotient of 1 and remainder of 0. So in all the cases, the remainder is 0. So that's why these four are the factors of 10. So if you just consider any other number apart from the factors, you will not get a remainder of 0. So just try to divide 10 divided by 3 and find what is the remainder. 10 divided by 4, 10 divided by 6, 10 divided by 7, 10 divided by 8, 10 divided by 9, and check whether the remainder comes as 0 or not. If it comes 0, then these numbers can also be factor of 10. But the remainder is not 0, that's why these numbers are not the factor of 10. Another way to find the factors of 10 is by writing 10 as product of two numbers. I hope you know what is a product. What does a product mean? Product is basically multiplication of two numbers. So if you see my screen, I have written 10 as 1 into 10. So 1 into 10 is 10 and 2 into 5 is also 10. So, is there any other way to write 10 as a product of two numbers? There is no other way because 10 does not come in the multiplication table of 3 or 4 or 6 or 7, 8, 9. So there are only two ways by which you can write 10 as a product of two numbers 1 into 10 and 2 into 5. So if you see there are four numbers involved here 1, 2, 5, and 10. So these four numbers can also be called the factors of 10. So what are the factors of 10? 1, 2, 5, and 10. So this is another method to find the factors of 10. Since we have understood what are factors now, let's understand what are prime numbers. So prime numbers are those numbers having only two factors. For example, if we consider 2, 2 can be written as 1 into 2. There is no other way by which 2 can be written as a product of two numbers. So 1 into 2, there are only two factors, 1 and 2 for 2. Similarly for 3, 3 can only be written as 1 into 3. So there are only three factors for 3, 1 and 3. Similarly for 5 and 7, they have only two factors, 1 and the number itself. For 5 it is 1 and 5, for 7 it is 1 and 7. If we consider 4, 4 is not a prime number because 4 can be written as 1 into 4 and 2 into 2. So there are three factors involved here 1, 2, and 4. So 4 is not a prime number. So prime numbers are those numbers having two factors only, 1 and the number itself. Now that we have learned what are prime numbers and what are factors, now we'll understand what is prime factorization. So prime factorization of any number is writing the number as a product of prime numbers only. So for example, if you want to write 10 as a product of two prime numbers, we'll write 2 into 5. So we just a few minutes back we learned that 2 is a prime number and 5 is also a prime number. So writing 10 as a product of two prime numbers, so it can be written as 2 into 5. So this is prime factorization of 10. If you want to take another example, suppose we take 12. 12 can be written as 2 into 6. Now 6 is not a prime number because there are multiple factors of 6. What are the factors of 6? Please check. There are more than two factors of 6. So 6 is not a prime number, but 2 is a prime number. So we'll keep 2 as it is. We'll write 6 as 3 into 2. So if you want to write 12 as product of prime numbers, we'll be writing it as 2 into 3 into 2. 2 into 6 can be written as 2 into 3 into 2. Again, 12 can also be written as 3 into 4. 3 into 4 is also 12, right? So now we know that 3 is a prime number, but 4 is not a prime number. Just a few minutes back, we learned that 4 has 3 factors. So 4 is not a prime number. So we'll again split this 4 as 2 into 2. So if you want to write 12 as a product of prime numbers, it can be written as 3 into 2 into 2, which is again same as this product 2 into 3 into 2. Both these products are same. So prime factorization can be done by two methods. One is called the division method and second is called the factor tree method. So we'll learn both. First method is division method. So earlier we learned how to write uh, 12 as product of prime numbers, which is 2 into 3 into 2. Since 12 is a small number, it is easier to write it as 2 into 3 into 2. But for bigger numbers like 66, we need some other method to find the prime factorization. So let's understand both the methods. First, we'll go with division method. So we want to find all the prime factors of 66. So which is the first prime number? First prime number is 2. So is 66 divisible by 2? Is 66 divisible by 2? So yes, 66 is an even number. What are even numbers? Even numbers are those numbers ending with 0, 2, 4, 6, and 8. So 66 is ending with 6. So 66 is an even number and all even numbers are divisible by 2. We know that. So what is 66 divided by 2? 66 divided by 2 is 33. We know this. If you want to check, you can check. 33 into 2 is 66. So if I want to divide 66 by 2, I'll write 2 here, which is a prime number. I'll write all the prime numbers on left side of this line and I will write all the quotients on the right side of this line. So what is 66 divided by 2? It is 33. So I'll write 33 here. Now 33, is it an even number? It is not an even number. So it is not divisible by 2. So which is the next prime number? So next prime number is 3. So is 33 divided by 3? So 33 is divided by 3. We know that 33 divided by 3 is 11. We know this. So 33 divided by 3. I'll write 3 on the left side and I'll write the quotient on right side. I'll write 3 on the left side. I'll write quotient 11 on the right side of the line below 33. Now, 11. Is 11 an even number? No, 11 is not an even number. So it is not divisible by 2. Is 11 divisible by 3? No, 3 into 3 is 9 and 3 into 4 is 12. So 11 does not come in the multiplication table of 3. So in which numbers table 11 comes? So actually 11 is a prime number. So 11 only comes in the table of 1 and 11. So 11 into 1 is 11. So we have to write 11 here and then below 11 we need to write the quotient which is 1. So we have all the prime factors of 66. Prime factors of 66 are 2, 3 and 11. So 2, 3 and 11. So 66 can be written as 2 into 3 into 11. So this is how we find the prime factorization of 66. So now that we have understood the division method, now let's understand what is factor tree method. So factor tree method is also similar to division method in some way, but the representation of all the prime factors is different in factor tree method. So let's understand how it is represented. So again, we want to find the prime factors of 66. We know that 66 is a even number and it is divisible by 2. So on the left hand side here, where a circle is drawn, I'll write all the prime numbers. And on the right side, where a rectangle is drawn, here where a rectangle is drawn, I'll write all the non-prime numbers. So I'll write prime number here, I'll write 2 here. So 66 can be written as 2 into 33. I'll write 33 here. 66 can be written as 2 into 33. So we know that 2 is a prime number, so we'll ignore it for some time. Now let's attend to 33. 33 can be written as 3 into 11, right? 3 is a prime number, 11 is also a prime number. So 3 into 11 is 33, right? So we have all the prime factors required for 66. So 66 can be written as 2 into 3 into 11. 2 into 3 into 11. So this is the prime factorization of 66 using factor tree method. Thank you.